Hey everyone! As the listener base of Chemistry for Your Life has been expanding, Jam and I have been brainstorming new ways to keep the show growing. Right now, our limiting factors are honestly time and money. So far, we've covered the cost of hosting the show for one more year, which is very exciting, and that is totally thanks to you guys buying merch and donating online to our Ko-Fi. However, if we want to expand to be able to devote more time to the show, to try new things, or bring on special guests, even just to maintain our audio equipment, we need to have the financial flexibility to do those things. Ultimately, with Jam being a freelancer, a lot of things are vying for his time, and this podcast having some kind of income will really help it make a priority for him. The same thing is going to be true for me. As I look to graduate in the next year or so, I'm trying to decide what career I want to have in my future. We would both love for this podcast to become less of a hobby and more of a career. And that would let us dedicate more time to making content and interacting with you guys. It would also help us keep all of our chemistry content open access and free of charge for anyone who wants to learn about chemistry, no matter what resources they have.
And one way that we've come up with to do that is by making a Ko-Fi Gold. So a few people have actually asked us about something like this. It's similar to Patreon, but essentially you can subscribe monthly at any amount, even $1, and you'll get special perks for doing so. Melissa and I don't want to put any chemistry content behind a paywall, but we will do some special non-chemistry content with our Ko-Fi Gold subscribers, such as give bonus icebreaker episodes or even a live Zoom Q&R. And starting now until the end of May, if you subscribe to be a monthly supporter on our Ko-Fi Gold at any amount, Melissa and I will send you a custom sticker and a handwritten note in the mail to say thank you. No matter where you are in the world, we will send it to you. We're going to try to do a little something special with our Ko-Fi Gold members a few times a year, so the fun will just keep on happening.
To support our show and get your sticker, go to ko-fi.com/chemforyourlife. Subscribe monthly at any amount and send us a private message on Ko-Fi with your mailing address so that we can mail you your note and sticker. We are so excited to do this.
Thank you guys so much for listening and for your support. We literally could not have the show without you. And now, on to today's episode.
Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast helps you understand the chemistry of your everyday life.
Okay, Jam, today we are going to walk down nostalgia lane.
Oh, okay.
I just hopped right in there. I didn't greet you, just for the listeners, so you know, Jam and I have just been in a meeting for an hour, so we've already done all our greeting, just for the record.
That's true. Yeah, that's true.
I'm not cold-hearted. I do care about how he's doing, which I assume is pretty good.
Yeah, well, you didn't even ask, so you wouldn't know.
Well,
just kidding. I'm good.
You're about to be better because we're going to walk down nostalgia lane.
Oh, okay. Awesome.
Okay, when you were a kid, did you ever have those markers where you colored with one color and then you had a clear or white marker that went over it and changed the color magically?
I did very much so have those.
Okay. So we're going to talk. We're going to undo the magic of magic markers, and we're going to talk about what actually is happening instead of magic.
Nice. Okay, cool. So this is meaning like not magic markers like some people call Sharpies and the like magic markers.
Right.
This is like actual magic markers.
The
like
color changing ones.
Color changing markers. Got it. Okay, cool.
Mm-hmm. Specifically that kind where you have another marker that changes the colors.
Okay, sweet.
Okay, and the reason we're going to talk about that is because we had an organic chemist write in. His name's Scott. He was really nice. He also mentioned that now he works as a patent agent. So there are chemists who work for patent agencies to check out the chemistry. And I thought that was good information to include because that just kind of tells you there's other things to do with a chemistry PhD besides just becoming a professor or working in research.
Right.
So he wrote in and said that he and his kids have color changing markers and he didn't know how they worked. And I felt like that was a really good question and a great episode idea for this week.
Dude, awesome. Sounds perfect to me too.
Okay, so here's the very basicest way of communicating what happens when you have a color changing marker.
Okay.
The clear or white pen that you write over the old marker that's already on the paper with causes a chemical reaction to take place only in the spot where you draw that marker.
Okay.
And that chemical reaction changes the color. So that's it. That's the basic explanation.
Right.
It's a chemical reaction right there. If you don't want any more details, you can just move ahead to the part where we talk about our weeks. But I want to give you more details.
Yeah, I was going to say that like leaves a lot of the mystery there where it's like, okay, maybe I would have guessed it's a chemical reaction.
But it's kind of a little bit complicated. So I just wanted to give people an out, you know?
Oh, okay. Yeah.
Okay, so all of these are going to be slightly different chemicals because they're different pigments or colors to make different colored markers.
Okay.
But generally, they're in your marker 1 is what we're going to call the colorful marker that you color with first.
Okay.
In marker 1, there are 2 different types of dyes.
Okay.
Usually 2 different colors of dyes.
Okay.
One of those dyes can be changed with different conditions, and the other dye will stay the same color no matter what. Well, no matter what it's exposed to in this scenario.
Okay. Okay.
So that's marker 1. Marker 2 has something in it that will change the conditions of the one dye that's able to be changed colors.
Okay.
Usually what it does is make the changeable dye lose its color.
Okay.
So instead of seeing the mixture of 2 dyes, you're now only seeing one of the dyes.
Okay. Okay.
Okay, does that make sense?
Yes, I believe so.
Can you say it back to me real quick, just so we make sure that we're tracking? Because it's kind of hard to explain colors with only voices.
That's true. Yeah, that is true. Man, if only you guys could see how amazing this looks. So marker 1 is the one we draw with first. It is colorful. It has 2 types of dyes in it. One that will stay the same in this scenario, even if we draw over it with a different marker. And another dye that is able to be affected by the other marker. It can be changed.
Yep.
So we draw a line with marker 1, and then we draw over that with marker 2. Marker 2 is able to make one of the colors that's one of the dyes in marker 1 turn clear instead.
That's right.
Okay, sweet. So then you're just left with one of the colors.
Right.
Basically.
So a good example of this is if you have a green marker. I don't know if this is actually the chemically accurate, but this is just to help you visualize it. If you had a green marker, green is usually made up of blue and yellow, right? So if you could somehow color over your green marker to eliminate the yellow, you'd only be left with blue.
Right.
That's basically what happens in a color changing marker.
Nice. Okay, cool.
So you have 2 colors and then you eliminate one of them to get a new color.
Yeah. Nice.
So that's a slightly more complicated explanation of what happens. Now we're going to talk about at the molecular level what happens.
Okay, nice.
Okay, so this is the nitty gritty. This may sound familiar to you because it is very similar chemistry to what happens in a color changing mug as well.
Okay, I was about to ask if it was related at all or if it was like a totally different kind of process because we talked about that mug sometime last year, I feel like. I can't remember.
Yeah,
it feels like
I
a
think
while
it was
ago.
about a year ago. This has come up a lot, but do you remember the word conjugation?
Yes, I do remember that word.
Okay, conjugation, it means alternating double bonds.
Okay.
Means other things in different contexts, but in chemistry, it means alternating double bonds. And those double bonds, the way they alternate, sort of makes it to where the electrons can move around and have a nice highway.
Mm-hmm.
And when you have that phenomenon of the conjugation with electrons being able to move around, if there's a lot of alternating double bonds, it's called highly conjugated.
Mm-hmm.
That is a characteristic of a molecule that has a lot of color.
Mm.
The reason it does that, we've talked about this in the bleach episode and even in the color changing mug episode, is because color is determined by the amount of energy that electrons can absorb, basically. We go way more in depth on this on the bleach episode.
Mm-hmm.
And something about the conjugated bonds allows the electrons to absorb energy in just the right range to give the molecule color.
Okay.
That's a very brief overview. If you want more in depth, you can head on back to the bleach episode.
Okay.
Okay. So we have pigments and dyes at play in these markers, and they are highly conjugated.
Mm-hmm. Mm-hmm.
And then you expose the highly conjugated dye to something basic, has extra electrons, and a reducing agent that does an oxidation reduction reaction, like we talked about in the rest episode.
Mm-hmm.
And both of those things add in electrons.
Okay.
Enough electrons to break one of those double bonds and make two separate single bonds out of it.
Oh, okay.
So basically adding in electrons disrupts the electron highway. It stops traffic. And when the traffic is stopped, it changes the way that the electrons can absorb energy, and therefore it can eliminate the color altogether.
Weird. Huh.
Mm-hmm. This is also similar to the concept we talked about in Why Things Fade in the Sun.
Right. Huh. Dude, crazy.
Yeah, it is crazy. And it really is a concept. It's come up so many times, but it still is just hard to grasp because it's just kind of weird that alternating double bonds means color. And if you break one of those alternating double bonds, that means no color.
Yeah, that's really strange.
Interrupts the flow. So just to summarize, in color changing markers, in marker 1, there are two dyes. One that is very stable and one that can be impacted as a result of the changing conditions that will be introduced from marker 2. When marker 2 is introduced, it will impact one of the dyes and make it colorless by literally changing the molecular structure of it. So once the molecular structure is changed, it's no longer a dye. Basically, it's just something else. Basically. That's funny because the base and the reducing agent cause it. That's a little chemistry joke for myself. So it changes the actual structure of the molecule to make it so that it's no longer colorful. And then you're left with just one color. The original marker, one of the dyes has been destroyed.
Dang. Wow.
So that's an overview of magic markers and how they work. So I've destroyed the magic for you, like the marker number 2 destroys the dye.
Wow. Dang. Yeah.
Do you want to take a stab at explaining that back to me?
Yes. So I think one of the things that helped me kind of visualize what's going on the best was you used the word traffic to describe what's going on at the molecular level in these markers in the dyes. So the dyes in marker 1, when you've drawn a line with it, we're seeing a lot of color. And that's because they have a lot of alternating double bonds or conjugation.
Right.
So the reason that they appear really colorful is that the with those alternating double bonds acting like a highway, like you said, they can move around very freely in a way that happens to be in the range of visible light and color to us that makes those dyes really colorful.
Yes. I will say, you said they move around, and that they is electrons.
Yes, right.
Because electrons are what make up bonds. A bond is made up of two electrons, generally shared electrons. And so the alternating double bonds are really like alternating pairs of electrons that can move around.
Uh-huh.
And they're the thing that absorb light and then re-emit the light, and we see light as color. Or they absorb energy, or, different things. We've talked about that a lot. Yeah. Don't want to get bogged down in the details for our magic marker situation.
Yeah. So we're seeing that. It's great. We're seeing the line we just drew with our marker number 1. Then we take marker number 2 and we draw on top of it.
Mm-hmm.
And marker number 2, being a violent little marker, has a lot of stuff going on that is about to disrupt what we just put on our paper with marker number 1.
Mm-hmm.
So it is very basic, right? Which means it has a lot of electrons that are extra that it basically sort of doesn't want, right? It would like to get rid of those if it can.
Yeah, usually bases are looking for something that doesn't have enough electrons.
Right.
And there's also a reducing agent in there that does something similar. It's trying to give away those electrons.
Nice. I guess you could think of it as like mean because it's destroying things, but also it has a lot and it's kind of being generous. So I guess it depends on are you like a bases are generous or bases are evil kind of glass half full, glass half empty kind of person?
Yeah, it's kind of weird because normally if electrons are taken from one molecule, given to another, or if they're shared, it's a positive thing. It's a good thing. Not a positive in terms of charge, positive in terms of you get good feelings, a new thing is made, everything's great.
Uh-huh.
But in this case, if a new bond is made, it's taking away from the highway of alternating double bonds. And so even though a new thing is made, it's also sort of destructive.
Mm-hmm. Mm-hmm. And that highway and traffic and all that metaphor kind of stuff made me think of you're adding all of these electrons in to what was a pretty healthy flow ecosystem, whatever you want to say, of electrons. Mm-hmm. Just like if you had, a highway that had a lot of cars on it, but it was flowing. Things were good. Traffic was moving. Everything was in a good, range of the amount of cars we've got on this highway or how many we can handle. And we've got a really good traffic system going. No one's getting bogged down and delayed on their way to wherever they're going. And then if you could just imagine being able to suddenly add a lot of cars to it, even though it can probably handle them in the sense it's not like everything just completely like explodes or falls apart. Our highways don't completely like just fall apart under the pressure of the cars. It does change the flow of things.
Yes.
Drastically, which in this case, for us seeing the visible light that is being absorbed and then re-emitted by these electrons, it changes that and we do not see it anymore. And the bonds change as well.
Yeah.
Right?
While you were talking, I also thought of a river. You've got a riverbed, and that could be the single bonds that make up the backbone. And then the water is these alternating double bonds that let electrons flow. Mm-hmm. And if you come and build a dam, even though that's building something new, in a way it's destructive because it keeps the water from flowing.
Nice.
And it changes the very nature of the river, and it can become a lake or whatever.
Yeah. Nice. Interesting.
So we are changing the molecular structure so that the electrons can't flow anymore. And therefore, they're not going to give you the same color that they did before. We're taking something and making it into something new.
But in this case, I guess it is a cool thing that is happening.
Yeah,
So-
it is really cool.
Yeah, it's destructive in a way, but also it's like the whole point.
Yeah. So, and we've kind of seen this theme happen before. We saw things fading in the sunlight because the alternating double bonds get interrupted or destroyed. That is by a different mechanism. It's by sunlight and energy, not by adding in electrons. Or we've seen that with the color changing mugs. That one was controlled by heat. There was an acid-base reaction, I think, that happened based on heat that moved electrons around. And then we're going to see it here as well. It's a reaction that moves electrons around to go from something very colorful to not very colorful.
Nice.
And because that's been kind of hard to visualize, I think, I'm going to go ahead and try really hard to remember. If this episode is out and you can't find it on social media, you can message us, but I'm going to try really hard to remember to draw out a little tutorial of what changes in the magic marker. I'll just pick one die and show how it changes so that you can visualize it.
Nice. Cool.
Okay, so that's it. I'm very impressed. You were hanging in there with me. I was a little worried about this episode.
Dude, yeah, it's definitely complicated, and it definitely is like very far removed from how we think of these things normally. So I think it is definitely challenging.
Yeah, some things have a very clear, oh, I get it, because in my everyday life, I can see this. But this one is, the ideas of color and light is more abstract. And that's always been a little bit more difficult for me to track with. So,
yeah, same, dude. I hear that for sure.
Well, that wraps up our chemistry lesson. Do you want to move into talking about our weeks this week?
Yes, I've got a small something that was kind of cool about my week this week. I decided to ring in the spring, which we are in now, I believe.
Oh, I know what this is going to be.
With making my first batch of cold brew for the year.
I knew it.
2021, I have not made any cold brew yet. So I started getting a little warmer and I got able to get my cold brew stuff unpacked from the box it was stashed in. And got that going the other day. And it's very exciting. It makes me feel like it's definitely spring now that I have cold brew. And I haven't had it in a long time. So
I also started making cold brew this week.
Nice.
So that's kind of fun.
We were on the same schedule, you know?
Right. It just seemed like time, I guess. But my cold brew is less intensive than Jam's, so I thought it would be easier. So that was part of why I did it too.
Well, yeah, it is. I mean, I guess it's like, even though mine's a little bit crazier, but it is nice because you do all that work up front, you know?
That's true.
It's over and you just have a batch of cold brew.
And that's great.
So I'm excited about that. That's a big deal. And I might end up tweaking my recipe a little bit more again this year. Who knows? We'll see what happens.
Who knows? It's your chemistry experiment.
What about you? What happened in your week this week?
Well, it was my birthday.
I knew about that.
You did know about that. It was just really nice. It was my second quarantine birthday.
Oh, yeah. Weird.
Yeah, was just on the very beginning of quarantine happening last year at this time. So it feels very different. Last year was sort of doom and gloom. It was dark. There was things that we didn't know what was going to happen. It was scary. And this year was hope is on the horizon. Vaccines are coming at us so quick nowadays. And it feels like things are going to change soon and go back to normal.
Yeah.
And that was kind of nice. And it was just kind of chill. I ate a lot of good food. I socially distantly saw some people and it was really fun. Our friend Miriam made me the cutest little cookie cake with some succulents on it. So that was precious. So it was a good time.
Dude, yeah, it was definitely fun. It was cool to get to see some people and do it in a safe way, but also get to like be outside. The weather was nice and feel a little bit like a chance to socialize, which is not nearly as common these days and stuff. So it was cool. I'm glad you did that.
Yeah, it was really a nice, I celebrate birth week. So it was a nice birth week, I would say. I got 4 new plants, which was really exciting. And our friends do a 30 for 30 gift basket, which is always really fun. And so I got 30 small gifts in a little basket. It was very exciting. And they were all perfectly on point. Exactly the kinds of small gifts I would want in a basket. And so that felt nice to be so known, including some Spindrifts, some Dr. Peppers, those little plants. It was very exciting.
Nice. Yeah. Yeah. Dude, that's fun.
Well, thanks, Jam, for, helping me celebrate and being a part of my 30 for 30 basket.
Of course.
And thanks for coming and learning about color changing markers. And thanks to all of you listeners as well for coming and learning about color changing markers, because we literally could not do this podcast without you. And it is so fun to be able to teach you guys every week.
And thank you for teaching us. And my childhood self would be amazed to know these details. I remember loving those markers. And you guys, please share your ideas of chemistry in everyday life with us. Melissa and I have some of our own, but some of the best ideas come from y'all. So if you have questions or ideas, reach out to us on Gmail, Twitter, Instagram, or Facebook at Chem for Your Life. That's Chem, F-O-R, Your Life, to share your thoughts and ideas. If you'd like to help us keep our show going and contribute to cover the costs of making it, go to ko-fi.com/chemforyourlife and donate the cost of a cup of coffee. You can give us 1 cup of coffee, or you can subscribe to give us a cup of coffee every month. And if you do that before the end of May, you will get a free sticker and thank you note from Melissa and I. But if you're not able to donate, you can still help us by subscribing on your favorite podcast app and rating and writing a review on Apple Podcasts. That also helps us to be able to share chemistry with even more people.
This episode of Chemistry for Your Life was created by Melissa Collini and Jerem Robinson. References for this episode can be found in our show notes or on our website. Jerem Robinson is our producer, and we'd like to give a special thanks to S. Navarro and V. Garza, who reviewed this episode.